Hi everyone, welcome to our first developer forum. I'm Nikki, I'm the CEO of RamaLama Labs, and joining me is Ian, the CTO of RamaLama Labs and the key presenter for today's forum. Now, the goal from today's forum for us is to help you all understand when you should be thinking of open source LLMs as a part of your projects, what might be some of the key challenges that you might face in this journey, and then how Ramalama Labs can make it really easy and cost efficient for you to deploy open source as a part of your strategy. We will be doing live demos of different types of containers that we offer, which can make it really easy for you to get any open source model up and running in a matter of a few minutes. And then stick around towards the end, we have some fun activities. We will be unveiling our Show Your Setup challenge where you get a chance to win a Bose headphones. And we also have some fun prizes to give out as a part of our raffle. All right, so with that, let's jump in. So typically, when you're thinking of different LLM based use cases, the natural inclination is to, of course, go with one of the closed APIs. So let's say be it GPT-4, Claude 3, or Gemini, and these are, of course, great. It's very easy to get started, but this strategy can be really expensive to scale. And then there's the other part where with every API call, you are sending your data externally. And so if you're working on privacy sensitive use cases, that can be a really big problem. And when you think of enterprise use cases, typically the problems that you're working on would be around document summarization or entity extraction or sentiment analysis. And honestly, for these types of use cases, you don't really require a 200 billion parameter model. These tasks can be done really well by the open source models, which are much smaller, faster, and can probably get the job done in almost like one tenth of the cost that it might take to run a GPT-4 model. So now, while open source, of course, has the promise of cost savings and data privacy, there are also two key problems that you should be aware of. So the first one is that let's say when you want to deploy your own open source model, you have to build your own AI infrastructure stack. So it would range from getting the hardware to setting up the runtimes to getting the models deployed and then managing the version compatibilities across each of these layers. It can be a challenging thing. And then the second thing is about the security aspects in this infrastructure stack. Now, with every layer in the inference stack, it introduces different unique attack surfaces, whether it's the tampered model weights or vulnerable runtimes. These can compromise the data integrity and the security across your deployments. And these are the key problems that we are looking to make solve with Ramalama Labs. And so, with that, I would love to hand it over to Ian to take us through a deep dive of some of these challenges and how Ramalama Labs is making it really easy for you all to get started on your open source journey. Over to you, Ian.
Thanks so much, Nikki. Awesome. Yeah, so this is going to be a bit of a mix, demo and discussion. And just to get us all started, I want to focus in the place that we're already familiar. So you've probably seen an interface like this, whether you're using ChatGPT or Claude or whatever else. It's a form, it's a GUI where you can send messages to and receive responses from an agent. Um, this is what we're all pretty much accustomed to using. But what's happening kind of under the hood here? So there actually turns out not to be any magic. So on that GUI, all that's happening when you send a message is an HTTP request is being sent off to a web server. The web server is processing a response and sending it back to you. So you don't actually have to do this with a GUI, right? You can use curl, you can use a programming language like Python or R or whatever you use in your stack. Uh, there's a top level where the user is interacting with the application. There's the HTTP request. There's a web server that's processing it. From there, the web server has to communicate with a runtime, which is the thing that actually resolves the model artifact. And this is where the complexity really starts to enter into the picture. There are a variety of different model runtimes. Llama CPP is a great one for self-hosting, for running things on your laptop, for experimentation, development, all of those sort of use cases. You might hear something like VLLM. This is a more common production environment runtime. All of these have their strengths and weaknesses. They do different things well. Um, Next to the runtime, there's the actual model that you're trying to serve. So this is the model weights, at the end of the day. But these are packaged in a variety of different ways. So you might see GGUF as a file type. And that's just one way of packaging it. It's not just the weights, but it's also how the model is served. So there's some nuance, there's some complexity for how the application is actually delivered and how those model weights are evaluated. In addition, there's complexity in the template, right? So this is how the chat is communicated back to the agent. There's a whole layer of stacked complexity that sits kind of inside these files. But again, there's different types. There's GGUFs, there's safe tensors, and there's not always compatibility across every runtime. Llama CPP, for example, only works with GGUF. VLM tends to work with safe tensors, but then there's others. There's UNCs. There's a bunch. You generally don't have to worry about that. You're going to choose the runtime that's relevant to you or relevant to your production setting, and then choose the models that are appropriate for that runtime. Sitting beneath that is accelerators. So it's one thing to get started deploying with CPU evaluation, but these are very large objects, very large models. They tend to benefit dramatically from GPU acceleration, matrix operation acceleration. And to do that, you need an accelerator, some software that can talk to the accelerating hardware underneath, whether that's the GPU, a custom NPU, whatever other infrastructure you're deploying on. So that could be CUDA, for NVIDIA, ROCm, Vulkan, AMD. It could be a variety of different accelerators, but how the runtime is built and compiled is going to be a function of the accelerator that you're trying to use. And beneath that still is the actual hardware. So there's a lot to this stack. And what we're going to do is kind of go through this stack in pieces and see how to break it up into reusable chunks. And you're going to find that there's a lot of complexity in each of these. So I already mentioned you have to compile the runtime specifically for each accelerator. Uh, the software stack that runs these is complicated, lots of dependencies, which means there's a fairly substantial attack surface to manage from a security perspective. If you do need these accelerators, there are additional dependencies which have to be bundled into any runnable container. And those are often very large, right? We're looking at 3 gigs plus for images, for a CUDA image, for example, in many cases. I already mentioned that the model artifacts are not always compatible, but the models themselves, if you're looking at a 200 billion model, parameter model, you could be looking at 100, 300 plus gigs. I think there was a Kimi 2 release recently that, you really need like 500 gigs of RAM just to run these things. So the model artifacts are their own layer of complexity into this whole stack. But let's see how we make this easier. So we split each of those pieces up into artifacts designed for different stages of the development process, where you can get started with a rapid testing prototype or moving into a production deployment, confident that there's a streamlined connection between what you're doing when in testing and what you're doing in prod. And we bundle all of these up with provenance, so you know and can verify where the model weights came from, with security scanning, so you know that the images themselves have been hardened and regularly recompiled. We make all of this as easy as possible to run, whether you're doing local development or going into a production environment. Um, uh, I'm excited to share a little bit about our hosted APIs as well, which are coming up pretty soon, where we're taking all of these artifacts and making them available to you in a hosted cloud environment so that you can see what will work for your use case without having to deploy it yourself. And then whenever you're ready, you can take, those same artifacts that we're running in the cloud and deploy them in your data center or in your cloud. basically, you're going to know that if you use our services, you can reproduce the exact same experience for your customers or for your company internally. There are three primary artifacts that this all boils down to. What we call unified images, runtime images, and model artifacts. I'm going to talk about each of these in a little bit more detail, but the high level, the unified images, it's just a single container that has everything you need to hit play and get a web server that will respond to agent request. Runtime images are more focused on that transition into production, where you're ready to start actually deploying this live, using them yourselves, and probably mounting your own custom models into the container. And then finally, the model artifacts. This is our repository of all of the open source models that you could want that have been vetted for licensing. You can deploy confident that these are secure, safe, and ready to monetize. Okay, so let's kind of get started. I'm going to jump out of the presentation here and show you our registry. Um, and the reason I want to focus on this is this is just a one-stop shop where you can go in and see exactly what models are available, choose which you need, choose which runtimes might be relevant to your use case. Um, for us, since we're just running this as a demo, I'm going to choose a smaller model, Gemma 3. It's only 270 million parameter model, but it's actually still quite powerful. Um, and if we jump in, you can see there's a substantial amount of documentation to help you refer to whenever you're trying to, deploy in whatever environment, whether that's Docker and Podman or Docker Compose, or Kubernetes as you move into a production environment. And these are not complicated to get started. If you're familiar with Docker already, I'm going to kind of walk through what these commands mean. So some of this may feel duplicative, but this is, a single command to pull the image down into your environment, a single command to run it. And let's go ahead and actually just run a model. So I popped over into a terminal here, and I've got this Docker run command that we just pulled down from our registry. And there's a couple of pieces here. So there's the run. This is just the instruction to actually execute the container. There's a -p flag. This is telling the Docker instance to forward ports on 8080 inside the container to 8080 on the host machine. So this is how we can actually access the web server. And then there's a reference to the running image. And this is a unified image. It contains both the model and the runtime all in one. So I hit enter, and we see a bunch of text come up on the screen. Basically, this is all good news. It means the server is up and running. And literally that's it. We now have a running AI model. If I come back over, we can even go to the built-in chat interface. If you prefer having this sort of experience, we can talk to the model, hello, and immediately get a response. This is what we saw right in the very beginning. But if we break it down a little bit, and I promised you that this is, the GUI is just kind of a special case of what's possible. But we can send a curl request, if you aren't familiar with curl, basically it's just sending an HTTP payload to our local service. We're exposing the web server as a OpenAI compatible API. That means it takes a couple of arguments. In this case, it's going to be, a model. We're using Gemma 3 here, and then a message. We sent the content hello, and the model responded, hello, how can I help you today? So this is all totally, bog standard. There's also a RamaLama CLI that if you're not already familiar with curl and don't want to deal with that, you can install and you can talk directly from the command line like this. So plenty of options there. These are the unified images. Again, go back. And just to like kind of bring this around to the image that we saw in the beginning, this view of the different layers of the stack, that unified image was composed of both the web server, the runtime, and the artifact. And we saw that. It was one container that we ran and we got a response. We didn't have to do any additional work. These are really great for local testing, local development, just kind of figuring out whether a specific model is right for you. There is a second type here, which is called a runtime image. And these combine just the web server and the model runtime. You have to bring your own model. They're more flexible. They're smaller because the image itself, at least the model itself, is not being bundled into the image. So for our CPU only image, it's under 5 MB. It's extremely light. Uh, it also allows you the flexibility to serve multiple models from the same runtime. Um, this is a better way to think about moving into production. So in terms of that life cycle, generally what you would see is starting with unified images as you're testing and iterating, and then when you start thinking about that movement to production, you switch over to the underlying runtime. And what we're going to do here is walk this through as an example in Docker Compose. And you can see, rather than a Gemma 3 reference, we're referencing a different image, which is the runtime itself. There's no model built in. And in fact, we had to bring our own. So we're going to mount a local directory that's going to contain our models into the container. And you can get models from a variety of places. There's Hugging Face, Olama, of course, our RamaLama container registry. All of these can be, different and useful depending on your use case. One thing that's special about our container registry is that all of our models are packaged as OCI compatible artifacts, and that means that you can use standard tooling like Oris to pull them, or even Docker. There's also some additional work to be done here in the command, but let's walk through that in a minute. So I'm going to come over uh, to a different demo where I've got that same Docker Compose script built out already. You can see we're going to be using a CPU runtime. We're going to mount our model, and then we're going to have some commands. But the first thing we have to do is actually get that model. So what I'm going to do is just pull it. And so Oris is a tool for pulling down OCI compatible artifacts. And I'm going to use, again, Gemma 3 as our example, and I'm going to extract it into this models directory, which we just created. And here we can see it. So there's this Gemma 3 270M GGUF file now. Okay, so we have our model, we have our runtime, and now we have to look at the command. So with a unified image, we're using Llama server as the web server. And there's a command to start that web server when the container initiates. Because we're mounting it with a without a pre-built model, we have to tell it where to start. And so we're going to open Llama server with the Llama server command. We're going to tell it which model it's going to serve, and we're going to tell it where to serve that model. So it's going to be on the local network on port 8080. All of these can be customized. You can add commands as you need. Okay, but once we're here, we have a Docker Compose, we have our model. It's just a Docker Compose app. Oh, and of course, I already had an instance of this running. So let's kill it and do Docker Compose app. And here comes our model again. And, this is exactly the same as before. This is just a web server. So now we've got the AI model running on our local network, and we can talk to it. So we can use RamaLama chat. Hello. And we can see it respond in real time. There's no difference. There's no magic. All of this is designed to make it as easy as possible for you to get started going. Okay. Docker Compose is great, particularly again for coordinating across many different services in a local environment, but sometimes you need an accelerator, right? What we've seen so far has just been deploying on a CPU. So what happens if you need, NVIDIA because you're running a larger model and you have some, NVIDIA GPU that you want to perform acceleration over? The key in this case is that you have to use an image which has been compiled for the runtime you're trying, or for the hardware that you're trying to run. And there is complexity here. Again, if you have an older NVIDIA model GPU, most standard builds are not going to be compiled for, 10 series anymore. But a lot of people are still running 1080 Titans or um, the like. So you need to find an image that's compiled for your use case, for your runtime. In our case, I've got a pre-built Llama CBP that's got CUDA. This is again on our registry that you can go and pull down. There's deployment notes in the same way I showed you before. In fact, let's just look. Um, at the top, we can select different runtimes, different accelerators, and different architectures. And when I go to CUDA, I can see here's a predefined customized deployment, Kubernetes deployment, that's going to use the appropriate image for the specified deployment environment. Um, so that's the real big trick. But let's actually see that in practice. I've got the same deployment YAML file for Kubernetes here. You're going to see a couple things that may look similar to the Docker Compose. If you haven't seen Kubernetes before, a lot of this is going to look like fluff. But the real magic that's happening is here in this container section. So we're identifying that we're going to deploy a container called Gemma 3270M. We're referencing a specific image. And now we've identified that it's going to be the Llama CPP CUDA variant. So it's going to have everything bundled in that we need to run on GPU acceleration. But then the last thing that's different is we have to actually add the GPU. And so this is the indication that when when the container comes up, that the cluster needs to add a GPU to it. But otherwise, we're doing the same thing. We're going to expose a port on 8080 and see what happens. So all of this can be run with a tool called kubectl. And just like Docker Compose up, kubectl apply is going to add this deployment to our cluster. And I'm just running at home, so this is my home cluster. So we can see the deployment was accepted, and I can find out if it's running. And there we go. We can see that it's live in the cluster. It just came up 7 seconds ago. This is Gemma 3270M. So now if we want to talk to it, it basically looks the same. Since it's in the remote cluster, it's no longer running on my local machine. I'm going to have to forward some ports from the deployment over to my local environment. But once I've done this, I am back off to the races. And I can go to localhost 8080 and talk to it just the same. So this doesn't have to be complicated. I think that's the high level takeaway. Whether you're deploying in a development environment or going into production, you can make this as simple or complicated as you need. The more of this that you try to do yourself, of course, the more complexity you have to manage. But it can be as easy as a single image command. So thank you guys so much. And with that, I'm going to hand it back to Nikki.
All right. Well, so you all saw our containers and how you can deploy them through command line. What we are also working towards next is our hosted API options, where basically you will be able to try out different containers and different models just via an API, the same way that you would probably use a GPT-4 API and so on. The big benefit being that it's going to be extremely cost effective for you because we are going to be working with open source models. Um, and it's going to be also helpful for you to, at some point, if you do decide for self-hosting, then we also are going to provide like very easy ways for you to like port over to your self-hosted environment. So stay tuned for more on this as well. We'll be sharing more information once we release out this feature as well. But in the meantime, we'd love for y'all to actually try out our containers. And we have a fun challenge here for y'all to motivate y'all to give it a shot. So we are doing this show your setup challenge. So what we would love for you to do is run one of our containers, You can do it on your laptops if you have a GPU in your basement, wherever you find it appropriate. Would love for you to see and run these containers. Just send us a picture, and then there's potential for you to win a Bose headphones or a Ducky One wireless keyboard. We have this challenge which is going to run until the end of next week. All you need to do is take a picture of your setup with running one of our RamaLama containers, and then we'll be releasing the winners by the end of next week. And would love to see you all give it a shot. Would love to hear feedback from everyone. And yeah, excited to see what you guys do with our work here. All right. Well, the way to share your pictures would be you can either, there's a channel in the Discord, you can send your pictures there, or you can tag us on LinkedIn or on X with RamaLama Labs, and yeah, we'll share the winners by November 14th. Really looking forward to see how creative you can get. All right. Well, and so with that, thank you everybody for joining in. Was really great to have you all here. Feel free to please reach out to Ian and me if you have more questions, if there are any specific use cases that you have in mind for which you need help. Any feedback on our product also, you'd really welcome that. And so looking forward to you guys experimenting, and we'll be sharing more as we build out our hosted APIs as well. So stay tuned and keep help us build out this community. Well, everyone, we're open to any questions, any comments you guys have. Feel free to either put your questions in the chat, or if you'd like to just unmute yourself and ask here for the rest of the group, please go ahead.
This is like, I mean, compared to other models used, like, did you do for any use cases, like, what would be the cost savings? Like, how do you sell this to the leadership, right?
Yeah.
I mean, I'm dumbifying the question, like, how do you sell this to leadership? Like,
Yeah. No,
what
of
is the
course.
key takeaway?
Yeah, of course. Actually, Ian, do you mind bringing up that first slide that we
Yeah.
have? Yeah, so to your point, Rohit, so of course, right, like, so this is where, if you see this table here, right, so if you see like different types, the way to think of the cost benefits is to think of it from like a use case perspective. And for, that use case, what kind of like, volumes are you going to see, right? Like, so in terms of like, what's going to be the size of your input tokens, output tokens, and also then like if you were to like for that volume, if you were to go with like let's say GPT-4 and or equivalent, versus if you were to actually like try one of the open source models, right? Because like obviously like an open source model is not going to do everything that GPT-4 does, right? So it's not like you can't think of it from like, oh, can it solve all of the problems? That's not probably possible. But when you think of like specific use case and the size of that use case, that is where then it becomes like easy to be able to show the cost benefits. Just an example here being, so let's say we take like document summarization for example, right? And so what would it cost you if you were to use GPT-4 versus if you were to use like a Llama 3 3.1, or an equivalent of that, right? And so that's where then you can see, right, like it can actually be like almost like uh, GPT-4 can be like almost 20 times more expensive than going with an open source version of this. So the way I would suggest is that think of it from a use case perspective, and then for that use case, what is an equivalent like open source model that can be helpful for that use case.
It's
So our
also
use case is to reduce the cost. So does it even orchestrate like for smaller requests, it chooses the best model? Like, does it do that or?
So, and I guess, of course, like reducing the cost is the key, I guess, business outcome. But do you mind sharing a little bit more on what is it that you're, looking to address? What is the problem statement that you're looking to solve?
So, so the thing is, we have all these GPT options, right? To our end users, they use like GPT-4, Gemini, Cloud, a lot of these different models. Users, like end users, mostly are business users, so they don't know what model to use at what time. Um, so we are trying to see if we can like build an orchestration system where the best model is chosen by default, no matter what, like depending on the request.
yeah, right. You can do that, but it requires some build out on your side. So oftentimes the way people will do that is they have a almost like a coordinator, an agent that sits in front of the routed call. So
Mhm.
and they'll identify the use case, the level of complexity. You have to kind of parameterize that for your situation, whatever services you need to provision. But that coordinator makes a determination about what the optimal model or the cost efficient model or whatever the thing is that you're trying to optimize for would be best suited to that task and then routes it appropriately. So you can kind of intermediate the request from the upstream user.
Got it.
And we're happy to, Rohit, like we could, sit down separately also and walk through some more details of your use case and build out like what can be the blocks, like the building blocks towards like that optimal solution that you're looking for.
Got it. So if I want to classify this product, like how do I classify this? Is it like Docker or is it like
It's
what is a container? Like how do I
containerized,
classify this product?
yeah, containerized AI artifacts. So, within the scope of deployment, if you're deploying uh, a containerized application, or if that's how your infrastructure is provisioned, then we'll give you everything that you need to get up testing in the cloud, and then take the exact same environment that you're testing on in the cloud down into your own infrastructure, whether that's your own cloud or a data center or whatever else. But you have that end to end ownership, and we'll give you the artifacts that you need to make that seamless.
Yeah, and Docker would be a mechanism that you can use to basically deploy the containers. But then it's not only Docker, like we can work with Podman as well. So it's actually like, yeah, so the product is pre-packaged containers, which will make these deployments easy, but you can use the choice of like what is easy for your developers, like whether it's Docker or for Podman, like you can deploy it using different options.
Thanks for the walkthrough, guys.
Yeah, of course. All right. Any more questions?
This is great. I think we're almost at time anyways. So
Yeah.
thanks everybody for joining. Again, we'll hopefully see you around on Discord. If you have it, go ahead. Feel free to reach out to me or anyone else if you have questions about how to get started with AI. I'm happy to meet and walk you through whatever your use case might look like.
All right. And do give our containers a shot and give us feedback. We'd love to hear back.
And Nikki, we're going to reach out to the raffle winners.
Oh, yes. Yeah. So, raffle winners, I'm going to ping you separately so that we can get your information to send you the gifts. So, please just look out for your DMs in Discord and we can chat there. All right. Well, thanks everyone
I'm
for
going to
joining
stay
in.
on if anybody has questions. Sorry, Nikki, I'm going to stay on, but Please. Sorry, Nikki, I didn't mean to interrupt you.
Oh, no.
Thank you, everybody. Have a wonderful day.
Thank you.
Thanks so much.